Hi guys, today we continue to study chapter 3 about energy. We first learn a new quantity called linear momentum. It is a measure of the tendency of a moving object to continue in motion along a straight line, defined by the object mass m times the object velocity v, p equal mv. It is a vector in the direction of velocity. Without a net external force exerted on a system, including a set of objects, remains the total linear momentum as a constant, no matter the objects interact with one another. This is a fundamental law of nature, the law of conservation of linear momentum. For example, skateboard. When a girl with mass m1 and velocity v1 jumps on a rest skateboard with mass m2, then she skates the skateboard at a velocity v2. Since no external influence is exerted on the total linear momentum of the girl and the skateboard does not change, i.e. the initial linear momentum Pi equals the final linear momentum Pf. Considering the skateboard without an initial velocity and having the same final velocity with the goal, we have from the conservation of linear momentum m1 v1 equal m1 plus m2 times v2. This expression allows us to find the final velocity v2 when the m1, m2, and v1 are given by 45 kilogram, 5 kilogram, and 4 meters per second, respectively. The result for the v2, the result for the final velocity v2 is 3.6 meters per second. For a collision of any two objects, the total linear momentum of them is conserved. Initial momentum equals the final momentum. The operation of a rocket is based on the conservation of linear momentum. At the initial, the rocket stands on the ground without a linear momentum. After ignited, the body of hot burning gases with mass m2 is rushed downward with speed v2, and meantime the rocket with mass m1 is lifted upward with velocity v1. The total linear momentum remains the same, equal 0. Therefore, we have m1 v1 plus m2 v2 equals 0, which determines the rocket speed as negative m2 over m1 multiplying by v2. For a rocket to be lifted with a greater speed, a larger mass ratio between the fuel and the rocket is required. In general, a multi-stage rocket is more efficient because it can have a big ratio of the masses. Similarly, we can define a momentum for the motion of rotation called angular momentum. It is a measure of the tendency of a spinning object to continue its spinning. Due to mass complicated, we will not go to detail in its formulation, but we should know qualitatively that the angular momentum of a spinning object depends on the object mass, shape, and the rate of spinning. This quantity is also a vector, and its direction is in the axial direction, or the direction of your thumb when you curve your forefingers along the rotation. Total angular momentum of a system is also conserved if there is no external influences. This is another physical law. For example, according to the law of conservation of angular momentum, a skater does not change her angular momentum when she draws her arms and legs to make the spin faster. If someone helps her to spin faster, her angular momentum changes due to the external influence. If she changes herself, the angular momentum does not change. In 1905, Einstein developed a theory that describes the effect of motion on space and time, called spatial relativity. In Newton's physics, space and time are absolute. There is no way to affect space and time. To develop spatial relativity, Einstein proposed two postulates. One says that all physical laws are the same in frames that move at a constant velocity with respect to one another. Another says that the speed of light in free space has the same value equal 3 times 10 to 8 meters per second for all views. The results obtained from spatial relativity indicate that a moving object has a shorter length, slower clock, and a greater mass. But the differences in length, time, and mass depend on the ratio of velocity between object and light, i.e., depend on v over c. V is the object speed, c is the light speed. For macroscopic objects, the effect of motion on space and time are negligible, not measurable, because the speed ratio v over c is very, very small. Another important result obtained from spatial relativity is the Einstein mass-energy relation. E0 equal mc squared, which shows that mass is a form of energy. We usually call this energy as rest energy. Since the speed of light is a big number, a small mass can have a huge amount of rest energy. Atomic bombs and nuclear reactors convert mass into energy. For some examples, the first example is to find the rest energy of a 2-kilogram object. From the rest energy formula, E0 equal mc squared, substituting numbers into mass as 2 kg and light speed c as 3 times 10 to 8 meters per second, we have the rest energy E0 equal to 1.8 times 10 to 17 joule. Another example is to determine mass needed to convert into energy per day in a 100 megawatt nuclear plant. Megawatt means 10 to 6 watt, 10 to 6 joule per second. So 100 10 to 6 joule per second, that's 100 megawatt. From the rest energy formula, we have mass equal energy divided by c squared. The total energy generated by a 100 megawatt nuclear plant in one day can be determined by the power. 100 megawatt multiplying the time of day. Substituting the power P as 100 megawatt, time of day in seconds as 24 times 60 times 60, and the light speed c as 3 times 10 to 8 meters per second, we obtain the mass that is converted into energy by this plant equal to be about only 9.6 times 10 to negative 5 kilogram. Little mass can have a huge amount of energy. That's the bi-nuclear plant. About 11 years later, Einstein developed another theory called general relativity. It is a theory that describes the effect of matter on spacetime. Special relativity is a theory that describes the motion, the effect of motion on spacetime. This one is the effect of matter on spacetime. According to general relativity, gravitation is represented by wrapping of spacetime. In other words, matter can curve the spacetime. There are 4 fundamental significant predictions and tests of general relativity, which are deflection of starlight by the sun, gravitational redshift, precessions of planet perihelion, and the time delay of radar echoes. Here I just list some the name and of the prediction test, and we don't go to details about this tests and predictions. This is the last chapter, last section of this chapter. One more slide is about my recent research. Recently, I published a paper in Journal of Modern Physics that develops a theory named light relativity, describing the effect of distorted spacetime on light. From this theory, I derived a new redshift distance relation that can perfectly explain the measurements of redshifts of light from both nearby galaxies and distant type I supernova. This result does not support the expansion and the acceleration of the universe. I just show my research a little. I have more other research on space and time. Thank you. That's the end of this chapter 3 about the energy.